Good morning and welcome everyone to Kaggle CareerCon 2019. My name is Addison Howard. I am a program manager on the Kaggle competitions team, and thank you for being a part of CareerCon with us this week.
I am Jessica Lee, a data scientist at Kaggle. We will be your co-hosts over the next 3 days for this entirely virtual event. We are very excited to be here with all of you as you learn how to build skills, get noticed, and get your first data science job. A couple of housekeeping items before we begin. Videos will not be posted online immediately following the event. They may be posted in the future, but please be sure to tune in each day live so you don't miss out on anything. Also, if you haven't already, make sure you join our Slack community channel so you can get to meet the rest of the community, ask live Q&A questions to the speakers, and participate in the digital career fair on the last day. You can join the Slack channel by clicking on the link below the video in the description. You will also find a link there to the CareerCon website, which has the full schedule and details.
All right, now that we have a couple of those logistics out of the way, get ready for 3 days of informative content, intriguing conversations, and practical insights on how to land your first data science job. Not only do we have a schedule for you packed with valuable seminars and engaging panel discussions, but we also have practical workshops to help you stand out in the recruiting process. But before we get into more details of the week, let's see how each one of us got here with some data that we gathered from tens of thousands of data scientists.
We asked data scientists to tell us the origins of their data science education background. The most common learning path? You taught yourselves. You might be surprised to find that formal university education didn't even make the top 3.
So this is just to say, no matter your path to becoming a data scientist, you're in the right place and you're not alone.
Data science is also a rapidly growing job market, and your skills are in higher demand than ever. According to the U.S. Bureau of Labor Statistics, in the next 7 years, there will be 11.5 million new jobs in the data science and analytics space. Kaggle CareerCon is all about sharing practical advice to help you land that first data science job.
So here's a brief overview over the next 3 days. To start off, we'll have seminars and panels from expert data scientists, hiring managers, and industry professionals from various fields. And each day has its own theme. Today, for example, the theme is all about building your skills. What skills should you learn? How should you delve into data science given your current background? Tomorrow's theme will be on getting noticed, and Thursday's theme is all about getting the job.
We also have a couple great events happening in Slack, so be sure to join our CareerCon Slack channel. Today, we'll have a digital job search mixer at the end of the day for you to meet one another and share your stories.
So we'll be back in just a minute with our very first session of day 1, which is a part of our API building workshop. So take a deep breath, fill up that cup of coffee, and settle in for a full day of data science. We'll see you soon.
I'm excited to kick off our first session of the day here with Kaggle's very own data scientist, Dr. Rachael Tatman. It's difficult to get experience deploying models before you actually have a job. Stand out by joining Rachael's workshop every day on building and deploying your own API, a great resume builder for potential recruiters. Rachael earned her PhD degree in linguistics from the University of Washington. Her personal research is on computational sociolinguistics, aka how our social identity affects the way we use language in computational contexts. She's an expert on all things NLP and has great perspective on what skills you need in a data scientist job today. Take it away, Rachael.
Let me try that with mute off. Good morning, everybody, or evening. I know some of you are out in the different time zones. So this is a 3-day event. If you miss one day, all the notebooks are public. You can go back and check some of the other days. And on day 1, we are going to talk about designing APIs, and then we're going to design an API. And then on day 2, we'll actually sit down and write our application using Flask and Python. And this is going to be all in Python. And if you're interested in using R, a lot of the same fundamental principles will apply. Day 1 would be exactly the same for you. For day 2, you could use something like Plumber, which is an API library for R. And then on day 3, we're going to actually deploy our APIs that we've built. And you have a choice here. You can either use Heroku or Google Cloud. We'll be using App Engine on Google Cloud. For both of these services, you're going to need an account, and we'll mention this and send you a reminder. If you're going to use Google Cloud, you do need to set up a billing. I don't expect you should get charged, but they do require that you have a credit card to set up a billing account to build an app, and that's an abuse prevention measure. And I know some folks don't have access to credit cards, so if that's you, we'll also talk about Heroku. We'll probably talk about Heroku first as well. All right, today I'm going to talk for some time about what a REST API is and the parts that make it up, and then how you would talk about and describe what's in your specific REST API. And then I'm going to, I have an existing little specification, and I'm going to edit it and add some things so you can see how that would work. And then finally, I'm going to head over to the Slack and answer questions. And I'm not going to take questions during the first portion, because what I've learned is that if I see a question, I will answer a question. And there were a lot of folks last time I did a live stream like this, so we're like, I would appreciate if the questions were at the end, so I could choose whether or not to stick around for them. All right, so REST APIs. The first question you might have is, why would you want to build an API in the first place? So I wouldn't really consider this a core part of a data science job. And of course, data science positions vary wildly. It may be something that's actually super important for your particular job and your particular company. In most instances, either a software engineer or a machine learning engineer is probably going to be putting things into production, or at least that's what I have seen happen in other companies, and it's sort of my experience. And of course, your mileage may differ. It's a very young field. Sorry, my earrings are hitting the headphone wire, and it's really distracting to me. Okay. And the reason that you would want to build an API is to let people actually use the model, or maybe you have like some visualization functionality that you've built, and so someone can send you a data frame and you'll send them back maybe JavaScript code to generate a really pretty visualization, or anything where you want someone to interact with your code in a programmatic way without having to go and download your code and run it locally themselves. And I personally really like working in notebooks, whether that's Jupyter or our Markdown. And there are some places where their entire stack is completely in notebooks. So Netflix, and I linked a nice little article here where they talk about their architecture and infrastructure, if you're interested. So Netflix does pretty much everything in notebooks. They're very committed to the notebook ecosystem. In some places, that is not the case. And if you hand your software engineers a notebook and like, here's my model, put it into production, they'll be a little bit miffed. So I have a little quote here from Jeremy Kuhn, who's a software engineer at Google. And he says, I think the truth is any software engineer worth their salt will refuse to put a notebook into production. They'll rewrite it from scratch if need be. And you may or may not be working with software engineers who hold that opinion, but some of them clearly do. And if you are working with someone who doesn't want to put notebooks into production, handing them a notebook and then having them like rewrite it, maybe even in a different language, is maybe not the best use of their time. So what you can do instead of giving them a notebook is giving them an API. And we'll talk about what an API is if you're not familiar. So basically, you'd give them a little application that you'd written that serves your model. And what we're going to be doing here is not going to be enough for you to put something into production commercially. So we're not talking about authentication. When we build our APIs, just anyone will be able to use them as much as they want, which is not usually ideal for commercial use cases. Usually want to like make sure that people are associated with an account. They can only get access to information their account has, permissions to access. And also, we're not going to be building any sort of database or storage backend. So we're just sort of building functionality where you send data, you immediately get information back, but nothing is stored. So that's another thing you'd probably want if you were going to put this into production. But we are going to get a good understanding of what goes into an API, the different parts, and then if you were to give sort of like a little baby API to your software engineering colleagues instead of a notebook, if they were of the anti-notebook for putting into production stance, then it would be a nice way of showing that you're a collegial person. And also, I use APIs all the time in my work, especially to get data. So I think the first API I ever used was the Twitter API, and I didn't know what APIs were or how they worked. I just knew that I wanted tweets that had a specific linguistic quality, and it was really rough. The learning curve was very steep. I didn't really understand what was going on. I was getting these JSON files. I didn't know what JSON was. And now, having learned more about APIs and started to work on my own, I have a much deeper understanding. And it's much easier for me to use APIs because I'm like, okay, that's a resource. That's the method associated with that resource. And then I sort of understand the structure of the APIs. What's an API? So API stands for Application Programmatic Interface. So to use an API, you need two applications, one that serves the API, and then one that's talking to the API. An application is just code you're using for some specific purpose. It's super vague. And we're going to be writing a Flask application to serve our API, and then you can sort of reach out to it once it's hosted using any sort of internet-connected Python environment you have, or not even Python. Sorry, that's something I didn't mention. So we're going to be working in Python, but you can query an API from any language. It's sort of like a web page without like a physical thing you can click on. So we're going to be creating a Flask app, but then you can create a different application to interact with your app, and that application doesn't have to be in Python, which is another benefit of APIs, because not everyone uses Python or not everyone uses R. Programmatic means that we're using programming. We're not going to be using a graphical interface with buttons like we see here on the Kaggle webpage. We're going to be using code to interact with our API. And then an interface means that the API is sort of the, I guess like the peanut butter and jelly in a peanut butter and jelly sandwich. So the bread on each side would be the two applications, and then the interface connects them and allows bread particles to travel back and forth, I guess. That's a weird metaphor. I'm going to scrap that one. You could also think of it like a post office. It's the API that has a set of rules for sending things back and forth and sort of tells you where things are stored. So in the US, we have things called post office boxes, where you can rent at a post office and then you can send mail to and from that address. And for an API that's hosted on the web, that address might be a URL address. And we're going to be using REST. There are other ways of building API. I have encountered REST the most commonly. If you have a different favorite, congratulations, feel free to use that one instead. But we're going to be talking about REST today. And this is based on Royal Fielding's dissertation, which you can read here, which goes into excruciating detail. So a couple of key concepts. One is client-server. So the client is what the person who's using the API is using to access the API. The server is where all the data is stored, where all the the code is run. And so you send a request from the client to the server, and then the server sends a response back. So just like if you're browsing the web and you have, let's say, this page, which is on Kaggle, I haven't downloaded the entire Kaggle site and all of Kaggle's databases and everything on Kaggle to my local computer, and I'm not navigating around it locally. I'm sending a series of requests to Kaggle from my client, the Kaggle server, and then I'm getting information back. So if I don't really want to hit anything because I'm going to move around to the page. But if I went down to data, it would sort of bump me down. And that was because I sent a request and it changed the page. Actually, I don't know that that's true. I'm not a front-end designer or a web developer. So yeah, feel free to let me know if that is the case or not, if any of the Kaggle team is watching in the Slack channel. We also have resources. So we don't just sort of like send a bit string and then it's appended to the end of the whole bit string and there's just like one big long file that's all of the data. It's organized. And I think as data scientists, this is something that we would expect data to be organized. We have some sort of background with data structures and data organization. And each little chunk of data or entity is called a resource. So my resource could be a text file. Maybe I've got an API that will go and get the text of novels that are in the public domain. I don't actually know if Project Gutenberg has an API, but if it did, it might have objects associated. It might have resources for each novel in its library. It might also have a resource for each author. We can also create links between resources. So I might say, oh, Victor Hugo wrote The Hunchback of Notre Dame or Notre Dame de Paris, and he also wrote Les Mis. And then I have a connection from one resource to multiple other resources. And then I don't want to get too deep into this, but the resource is like the file itself. The information about the resource is called a representation. It's sort of like an envelope that goes around the resource and includes the resource. And whenever I say resource, I mean a resource plus its representation, and that's where the representational in REST comes in. And if you care, there's a lot of resources out there. So we have a client and a server, we have resources, which are objects we can pass back and forth. We can get copies of a resource from our server. But how do we do this? What are the sort of verbs in this language if the nouns are the resources? And the answer are methods. So REST APIs are almost always served via web pages and HTTP. And there are a small set of methods, and these 4 are probably the most popular. There are a lot of other ones that people have added over the years for specific use cases, but these are the ones that we're going to talk about. So get is just sort of it's like a SQL query where you just return some data without changing the underlying database. So I can get information on resources without changing them. Since we're not going to have any resources actually stored, we don't have a database backend, we're not going to be using Git because we would have to have some place to store the resources and their representations to go and get them. Post creates new resources. So this is what we're actually going to be doing. We're going to be creating a new resource, and then because we're not storing it, it immediately disappears. But before it disappears, we get some information back as defined by the API. Put, which we can use to update existing resources. So if Victor Hugo came back to life and wrote another novel about being a playwright in New York City, we could we could use post to create another resource that was the new novel, and then we could use put to update Victor Hugo and say, oh, also he wrote this novel. I forget whether I said it was a novel or a play. I guess I'm on a Victor Hugo kick right now. And then delete, which is what we use to remove resources. So we have resources, which are objects. These are our nouns. We have methods, which are our verbs. And we're not actually going to be creating any resources, but I think it's important to understand, and especially when you are interacting with APIs that have big databases attached to them, which is most of them, that is how you will interact with them. A little redundant there. Okay, so I have built a little sample API for this that we're going to be working with through the series of workshops, and it does something kind of dumb, but useful. I see a lot of questions on how to get from a big chunk of text or a corpus of text a number of different, what's the word I'm looking for, to get in the instance and location of specific words. So maybe you have a list of company names that you're interested in, and you have a big list of patents, and you want to find out which patents have specific company names in them. And there's a lot of commercial products that will do this for you, but this will do the same thing. And I am specifically going to be getting the names of data science packages with an eye towards applying it to the Kaggle forum data, which we have shared publicly on Meta Kaggle dataset. So we could look at the popularity of different data science packages over time, as discussed on Kaggle, et cetera, et cetera. And my example that exists so far, I have the Python package names, and then with you guys, I'm going to be building additional functionality to get the names of our packages, R the language, not our, like the ones we own. But before I sit down and start writing any Python code, I am going to think about what I want my API to look like. What do I want it to actually do? And how do I want people to interact with it? At Kaggle Days last week, Francois Cholet gave a really, really good talk about user-centered design. So in developer tools specifically. So I can think about this as, okay, I'm imagining I'm a user of this, because probably you're going to use it in the future. What do you want your process to be like? So what do I want my API to do? I want to send it some text and get back the location in that text of any Python packages if they exist. And we want to pass into it some sort of text. And we want to get back information on the keywords we found and where they are. And I am returning this information with the character index of the specific word that I'm looking for, because that's sort of the standard in a lot of NLP, and that will let me use this data output with a lot of different other things, other programs, other algorithms. So to answer those questions, we want our API to tell us where specific keywords appear in our text. And I'm going to pass in a JSON file. And the reason that I'm doing this instead of just a flat text file is because this is going to give me the ability to later on, if I want to add additional information, if I want to start creating resources, if I have a JSON file, I can add additional information in that JSON file, and I'm not going to have to change a lot of the sort of like plumbing to deal with a different file type. And then I'm going to get a JSON file back with our keyword matches and where they occur in the input text. And it's fairly, in my experience, the most common file type to pass to and from APIs is JSON. That may change in the future. I think it used to be XML. Again, I'm not a web developer, but this way it's a little bit more in keeping with the standards of APIs in general. And if I have a script that works on data from a different API, it should be able to work pretty seamlessly with data from this API because it's both going to get JSONs back. So once we break, if you want to spend a little bit of time working on this, think about what sort of API you would like to design. And of course, you are perfectly welcome to follow along with my code example and do exactly the same thing. But if you want to do something a little bit different, maybe you've got an image processing algorithm you want to use, or you have some sort of XGBoost model you want to apply to data, that is also something that you are absolutely welcome to do. And I want you to spend some time thinking about what you want your API to do, what you're going to pass in, and what you're going to get back. And then for if you're going to be doing multiple things, and I'll show you what I mean by that, you want to do that with each of the things that you're doing. Okay, so we don't have to just rely on asking ourselves questions about what we want an API to be like, however. Little sip of coffee. We can rely on the really, really rich ecosystem of existing tools for this. So there's actually a couple of ways to specify what's going to be in an API and what it looks like in the design. And I'm going to be using OpenAPI here. Oh, no. I added that in a new window, sorry. So OpenAPI used to be called Swagger. I've picked this particular one, A, because it's open source, and B, because it has a lot of really nice tools around it. So we can, for example, you can see that there's Swagger code gen that will allow you, if you have a specification, to create the code for an application that meets that specification just automatically, which is really nice. And it's also very easy to generate documentation from your specification once you've written it. And if you're working on a company and they're using a different specification framework, use that one instead. Don't sort of like go reinventing the wheel and creating something that's not going to, gel well with the rest of your colleagues' work. So this is sort of the absolute minimum specification. And we'll go through the parts here. I go through them in more writing down here. So the first thing is that I want to specify the version of OpenAPI I use. I think the most recent one is 3.0.2. I've just picked 3.0.0 because it was the last major release. And I personally find it annoying to keep up with very minor releases unless it has something that's going to affect me particularly. And that's just my personal feelings as a developer. And then I have information about the application, the API that I'm developing. And each of these are required. So I have a title, a package name extractor. I have a description. This is an API that accepts a text string and returns package names in it. Sorry, this line overflowed a little bit because I'm really zoomed in. And then this is the real meat of the specification. So each specific activity or task you can do on the API with the API needs a specific URL. And that's how, when you serve the API, people are going to be able to use it. They'll be able to say, send this piece of information to this URL, and then you'll get your information back. Or if there is information back from that specific method, you'll get information back. This URL is going to be appended to the end of my URL for my API that I'm serving it. So if it's on Heroku, it'll be like Heroku.myapp whatever .url maybe, I don't know, I don't remember, slash extract packages. And if I had other things that I wanted to do within extract packages, I could have additional slashes here and create a hierarchical structure. So just like a file structure in a computer, you can have a hierarchical structure within your API. This is a very simple API that does one thing. So we do not have a hierarchical structure. This is a post method. So remember I talked about post, get, delete, and the fourth one previously. Post, get, delete, push, update, push, I think. So from that selection of methods, you should pick the one that most closely resembles what you're going to do. We are, like I mentioned, we are just creating a resource that is not going to stick around. It is passed into some Python code. That Python code is run. We get output back, and then the resource immediately disappears because we're not storing it. A description. So this is what this particular method does that extracts package names. The request body are the things that we need to send in. So the description is the what we want to be in the request. So you can see that I've said it's required, true. So we need to send some text in to get package names back. Otherwise, it's not going to work. And we are sending in a JSON file that I think I mentioned. And I say here that I expect the JSON file to be a single field containing text to extract entities from. So basically, I'm just putting quotes and curly braces around some string of text that I'm interested in to make it parse as a JSON file. And then responses. So this is a response code. So this is something that once we make our request, our server is going to send back to us. You may be familiar with 404, which means resource not found, I think. So if you get a response 404, it means the server's like, I looked, but it wasn't there. A 200 means everything's fine. Whatever you were asking for, it happened. And so if the server sends back a 200, which is a good job code, we're going to get back whatever the output is from the code inside our app, our Flask app that we're going to write tomorrow. And this returns the names and indexes of packages in the provided text. And I could even say character indexes here just to be a little clearer. So this is the very minimal example of a API specification. And I'm actually going to edit it, and I'm going to add a second method. So I believe I put a link in here, yeah, to the Swagger editor. So the Swagger editor is a free online editor. You do not need to, what's the word I'm looking for? You don't need to sign up for an account. You can just use it. And this is an example app when you open it, the Swagger Pet Store. And you can see that this is a much more complex, API than what we're building. So you can see that this one has responses 400, description, invalid ID supplied, 404, order not found. This is if you're trying to use the delete method, and it's specifically for orders associated with a store. So you can see this sort of hierarchical item. You can see this hierarchical structure here. And what I'm going to do is be super fancy and just copy and paste my API specification from my notebook into the editor. Choop, choop, choop. Oh my gosh, sorry. It's scrolling very slowly. It's probably because I'm streaming. Nope. Let me close all these other tabs so I don't get confused by them. So this is going to give me an error because I haven't finished describing my post method. So let me do that right now. Doop, doop. All right, I'll do a, just for me, I'm going to add an extra white space in there. Okay, so this is our API specification for the very minimal package name extractor. So I mentioned that I already had the Python code written, and I wanted to add our code. And what I want to do is create two methods, one of which will return Python packages and one of which will return R packages. So the first thing I'm going to do is I'm going to copy and paste this, and it will absolutely give me an error because I'm defining the same method twice. Yep. Duplicated MacBean key. And I'm going to edit my first method, and I'm going to say extract packages. Oh, wait. Underscores are bad in Python. And this I'm going to call extract packages R. And there is, oops. Sorry, you don't need to say paths twice. You only need to say that once. So now we have, you can see that this little interactive thingadoogle has updated. We have the Python version. It's got a request body required. On a 200, it returns the names and indexes of packages and the provided text. It returns application.json. It takes in a JSON file. And then we have the R package extractor as well. And I'm just going to update this. Python package name, R package name. And I think that's enough updating. I think that's pretty clear what each of these does. And they are more or less going to be the same from the API's standpoint, but the difference is going to be that the R package method is going to use different Python code than the extract packages Python. It's going to apply a different method to the data that we send in. So if we sent in the same data to both post methods, we get different output back, is the idea. All right, that's pretty much all that I had to talk about. So what I'd like you guys to do, and I'm gonna go and answer questions now, but if you don't have questions, you feel free to use the rest of the time to work on this, is think about what API you wanna design, what do you want it to do, some more ideas. You could, if you've done sort of like the dog or cat detection thing, you could create something that takes in an image and returns whether or not the probability that it contains a dog and the probability that it contains a cat. I will warn you that the Heroku free API option will not accept images. Or it will accept images, but they have to be extremely small, which is why I picked a text project. So if you are doing an image project, maybe something that you would expect to have very small images from. Other examples, you might just have an API that you send in a number and it tells you if the number is odd or even, which is like, I don't know, kind of a silly thing for an API, but pretty quick to write the code from. Of course, you can serve a TensorFlow model, an XGBoost model, a PyTorch model, whatever sort of machine learning model you would like through an API as well. That's going to be a little bit more finagling, but I have faith. And those are the exercises for today. And tomorrow we are going to actually sit down, write the Python code, write our Flask app, and create our API. And then on Wednesday, we will serve it. Nope, on Thursday, we will serve it. And I'm ready to go for questions now. I see Jessica popped up. Do you want to take over, Jessica?
Thanks, Rachel, and thanks to everybody for tuning in. Now moving into live Q&A. We do have one question from a user. Her name is Rachael.
Seamless.
What are the pros and cons of building APIs by ourselves versus using products like SageMaker? And how would you put these on things such as like cost for developing it, security, etc.? And this person is less concerned with the time taken to build the API in this component.
Yeah, that's a really good question. So it's going to depend. Actually, I guess I can look at you guys. Hi, guys. I've been here the whole time. Yeah, it's really going to depend on your specific team. There's a sort of like the general trade-off between open source, building it yourself, and using a commercial product that does it is developer time. So like my personal website is open source, and I've sunk quite a bit of time into that. But if you use a commercial product that builds websites, then it'll be faster, but it costs money. Some benefits of using a different service is that sometimes they will handle things like authentication and backend integrations for you. You have access to people who will answer your questions and help you out. That's not fair. You absolutely have that in the open source community, but it's not their job. So it can, there might be more lag, people have lives, you're sort of relying on the goodwill of the community. A benefit of doing things in open source is if something's broken, you can fix it, or you can ask to fix it and maybe they'll say yes, or maybe they'll say, actually, you broke it worse a little bit. It's really going to depend on your particular use case. Another thing to think about is software licenses and whether the license for the specific type of software that you're using allows for commercial use, because not all of them do. Great. It's a complex tapestry.
Yeah, it definitely is. Thank you so much, Rachel. We've reached the end of our session, but thank you all for participating in day one of the API workshop. It is a little early in the day, so if you have any further questions, Rachel will be sticking around in the CareerCon Slack channel afterward to answer them. So be sure to tune in again tomorrow and on Thursday at the same time as today for the rest of the API workshop. We'll see you all in a couple minutes for the next session.